A fire-breathing giant rests in the heart of the Mediterranean. The volcano of Santorini. It's haunted the Aegean Sea since time immemorial, and it's left its mark. A gigantic eruption 3,500 years ago may even have brought the mighty Minoan civilization to its knees.
This event, this natural disaster, must have killed thousands of people.
But how realistic are theories the volcano triggered the Minoan demise? Could insights gained from ancient or recent events provide the key to understanding prospective eruptions of Santorini?
When this volcano erupts again, it won't just spell the end for a few sheep like in 1650. It'll mean serious casualties.
Now a trailblazing expedition is set on finding answers to the many mysteries of Santorini. By drilling hundreds of meters into the ocean floor to extract sediment cores, the International Ocean Discovery Program aims to decode the complete anatomy of the volcano and its history for the first time. And they want to understand how the volcano might behave the next time it erupts.
If the eruption is powerful enough, it won't be totally trapped under the sea, and it'll blast up through the sea surface. And in doing so, will generate tsunamis.
This is a scientific expedition to understand exactly how the Santorini volcanic field works, and to unveil the fate of a once mighty Mediterranean civilization. A forbidding black cloud of ash rises over the Isle of Santorini. For days, heavy tremors have rocked the Minoan stronghold. Now the volcano at its heart has begun to hurl searing hot ash, rocks and gas up to 35 kilometers into the stratosphere. This is what the Minoan eruption may have looked like about 3,500 years ago. But what exactly this eruption and others like it must have meant for the people, their island home and beyond, is uncertain. Potent questions remain unanswered, even though this is an exceptionally well-studied volcano. But that is set to change. Scientists on board the international research vessel JOIDES Resolution are on a groundbreaking mission to decode the mystery of the Santorini volcano.
So this kind of work is important because, of course, volcanoes are a big hazard. They kill people, they affect people's lives.
Extracting cores from the heart of the volcano's underwater caldera, the team from IODP hope to piece together its history. It's the first time this has been attempted with such a highly explosive volcano.
One of the general features of these kinds of volcanoes is that they exhibit a kind of cyclic behavior. So with large eruptions, large explosive eruptions, relatively rarely, and much smaller eruptions much more frequently.
But why drill deep into the seabed when there are clearly defined sediment layers above the surface, including on the island of Santorini itself? What can you hope to discover?
If you look at a map of the world, you'll see that actually 2/3 of the Earth is covered in the oceans. So if we want to understand the Earth as a system, we need to access that environment. And the only way we can do that is via something called scientific ocean drilling.
I think IODP is basically as important as NASA is for space. So we know that climate changed in the past. We know this because of this drill ship, basically. We know about volcanic eruptions in the past. That's also because of this drill ship. With this drill ship, we could prove that the continents were drifting. Basically, everyone around the world has at least known or heard of one piece that IODP has contributed.
The International Ocean Discovery Program's JOIDES Resolution is a unique research ship. Repurposed from her old role in the oil industry, she has been investigating the oceans for the last 40 years. She's like a floating state-of-the-art laboratory where drill cores can be analyzed as soon as they're brought up from the ocean floor.
These materials are always the first time anyone has seen those materials. They're recovered from the seafloor from a place where no one could ever access them except through scientific ocean drilling.
The work takes 117 people, from drill technicians to the ship's crew and an international team of scientists. They aim to piece together the results of their analyses like a giant puzzle, to trace the volcano's behavior over millennia. And crucially, they'll try to predict the future.
The more we know about what happened in the past and how it happened, the more precise our predictions about possible future scenarios.
We know that it had this huge eruption 3,500 years ago, and an eruption like that would be pretty catastrophic, I think, in the middle of the Aegean, with all the islands around, with the tsunamis it would generate and so forth, and would certainly wipe out Santorini.
Scientists know masses about Santorini above water. Professor Stephen Sparks has studied the volcano's geology since 1973.
If you look at the cliffs that make up the caldera wall, you can see lots of different layers of white and red and grey. And these represent earlier eruptions, maybe tens, even hundreds of early eruptions of Santorini. So this has happened before. This volcano is cyclic. It goes through cycles of building volcanoes, having big eruptions, and then destroying them and forming calderas by collapse.
So far, terrestrial deposits have identified at least 12 major eruptions and many smaller ones going back 650,000 years. But 3,500 years ago, the Minoan eruption struck with unprecedented force, the most powerful in the last 10,000 years. Tracing the exact sequence of events could tell us why it was so destructive and provide clues to possible future disasters. The island as it was then was completely destroyed in the process. What happened can be broken down into 4 phases.
The eruption started with this pumice deposit. This is a deposit of lumps of very frothy rock.
Volcanic gases on the way to the surface mixed with molten magma to trigger an explosive eruption.
We estimate the eruption cloud went up to about 35 or 40 kilometers well into the stratosphere, and a lot of the very fine particles were blown all over the eastern Mediterranean.
This first phase likely lasted just 1 day. In the second phase, seawater combined with the hot magma. The resulting steam intensified the eruption into a superheated mass of steam and frothy rocks.
Instead of going up high in the atmosphere, they flow down the side of the volcano, and they flowed around everywhere as far as we can see, covering the island landscape.
The original island was destroyed entirely in the next stage.
So the third phase of the eruption not only has white pumice and ash, but it also has these big black lumps of rock. And we think that's basically the old island being completely blown apart.
But much worse was to come.
I'm on the beach on the south coast of Santorini. Behind me, you'll see these cliffs of pumice and ash and rocks, which were formed in the 4th phase of the Great Eruption.
The ejected material must have reached about 500 degrees Celsius and flowed into the sea at speeds of up to 200 kilometers an hour. Today's iconic caldera is thought to have formed in this final phase, when the surface of the magma chamber collapsed into the now partially emptied void below. Ash flows reaching the sea triggered tsunamis.
This was the height of the Great Eruption. If you add all that together, that makes this eruption on Santorini in the Bronze Age the largest known explosive eruption on Earth in the last 10,000 years.
Defining this volcano's eruption cycle is a crucial expedition objective, to recognize renewed danger and react to it in time. Secrets must lie in undisturbed sediments on the caldera floor. Interpreting the past of the Santorini volcanic field could let the scientists predict its likely future behavior. The team on the JOIDES Resolution face a daunting challenge. They have to drill 6-centimeter wide holes into the sea floor about 500 meters below the water surface. It takes precision engineering.
So we're just about to go drilling now.
Remotely controlled from the ship.
So everything on this rig is gravity. So the large dial in front of him, the yellow needle is the physical weight of the drill string hanging underneath the rig, and the white needle shows him how much of that weight he's applying. We can't push because our drill string's very flexible. It's like spaghetti. It's like we're trying to drill with a shoelace. If you just dangle a shoelace and try and put some weight on it, it just bends and collapses. The most critical part is us drilling down, making sure that our calculations are right and drilling down to the right depth. If we drill too far, then there's a gap in their core record for the scientists. Then there's a piece missing of the Earth's history.
Not least, operating so close to the island's steep shoreline is notoriously difficult. But the sediment cores retrieved from the depths of the caldera are worth the effort. They hold the key to the volcano's past. The marks left by the Minoan eruption 3,500 years ago are a striking warning of what an event that size can do to its surrounding. At the time, the Aegean was already home to highly advanced civilizations. At their helm were the Minoans of Santorini and Crete. And the eruption's aftermath was to have a momentous impact on their people.
So it was a really colossal event. The eruption undoubtedly affected the whole of the Eastern Mediterranean and the people living there at that time.
It can't have come as a surprise to the Minoans that they were living beside an active volcano.
There was the same crater that we see, huge volcanic crater formed by an earlier eruption 21,000 years before. But in the middle of the crater, there was a much bigger new volcano that had grown up. And that island occupied most of the volcanic crater.
Ash deposits show that the volcano must have generated smaller eruptions ahead of the main event.
We know in modern volcanoes, those precursors can go on for days, weeks, months, even years before a big eruption. So the Minoans would have known something was not quite right, and it's possible that they actually left the island. We don't really know. No bodies have been found. Now, of course, once the eruption starts, that's it, I'm afraid, for people who lived on the island.
The Minoan eruption was an event of extraordinary magnitude, far more destructive than the infamous eruption of Mount Vesuvius that buried Pompeii.
They would have been raining down hot, big lumps of frothy rock. They really would have had no chance of surviving. Perhaps some of them had sheltered in buildings. They might have escaped that phase. But as soon as we got to the second phase and the seawater got in and we got these explosions and these flows going down, they would have been moving at maybe 100 and 200 kilometers per hour. There would have been really no hope for anybody surviving.
Archaeological excavations on what is now left of the original island of Santorini have unearthed the astonishing remains of the Minoan town of Crete. The town was in the volcano's direct firing line. Shards of crockery, vases, beds, entire walls and even streets were left preserved for eternity by the volcanic ash. The finds testify to the wealth and advanced culture of Minoan society. But evidence of renovation suggests that parts of Akrotiri had been repeatedly damaged by earthquakes and repaired. Apparently, the population was prepared to put up with the hazards of life on an active volcano. But the last eruption to hit the town surpassed all that had gone before. It buried Akrotiri completely beneath thick layers of ash. Yet, no evidence of human victims of the catastrophe has ever been found on the island. Perhaps a series of unusually severe earthquakes preceded the eruption and led the inhabitants to leave Santorini before disaster struck. For although everyday belongings were left behind on the ruins of Akrotiri, no easily transportable valuables like jewelry have ever been found. It seems likely the people of Santorini would have made their escape to neighboring Crete. Archaeologist Constanze von Rüden has been on the trail of the Minoan civilization for many years. Here on Crete, she's trying to decode what their society might have been like. Crete was the beating heart of the Aegean powerhouse that was the Minoan Empire, an empire of seafarers and traders. The Minoans forged alliances far beyond the shores of their islands. They were wealthy and well-regarded right across the Mediterranean. Their extensive trading networks gave the Minoans the edge on their peers. Fresco paintings found in Akrotiri and Cretan Knossos provide detailed insights into Minoan life at the time of the eruption. The artists used a palette of intense colors made from natural pigments for realistic depictions of daily life, of landscapes, plants, and animals. Impressions of nature seem to have particular significance.
Some nature elements are brought right into the palaces with these paintings. It seems to have been so important that they wanted to have them in these central points of political power.
In other words, could a natural disaster on this scale have shaken the Minoans' faith in their belief systems and power structures? Was this the wrath of the gods? It seems likely. Certainly, Santorini was a key trading and cultural metropolis, central to the Minoan economy and power structure. Its irretrievable loss must have sent shockwaves through society. And the long-term effects? Could the gigantic volcanic eruption on Santorini have spelled the end of an entire civilization? Geophysicist Professor Paraskevi Nomikou comes from Santorini. The volcano has fascinated her all her life.
As I was born in Santorini when I was a child, one of my dreams is to see what is happening on the seafloor. And I was always listening to stories from my grandfather when I was a little girl that the most active volcano is not on land, but is also at the seafloor.
For Santorini natives, insights from this expedition are of immediate interest. They know the volcano that's their home can also spell their end.
The scope of this expedition is to understand how many volcanic eruptions occurred in the last 3 million years. We have studied the geology of land, but we don't know anything about the sub-sea floor. And that's why we are here. We want to have samples, sediments from the sub-sea floor and go as much deep as we can. Because if you study the past, you can understand the present and you can predict the future.
The scientists on the JOIDES resolution are sure they can reconstruct the volcano's past eruptions right back to the very first one. This data should allow a realistic projection of probabilities, eruption cycles, and the extent of likely future eruptions. But what will scientific ocean drilling reveal in the ocean floor hundreds of meters below the surface? A new core segment is brought up every 30 minutes. The scientists work shifts, beginning the analysis immediately in the on-board laboratories. Color, consistency, and composition are described in detail, catalogued, and samples taken from every ash layer for further analysis. It's the start of a long and painstaking process.
Any idea on what it is?
I think it has a lot of volcanics in it.
Yeah. We could call it an ash.
We could call it an ash with mud.
Yeah, let's call it ash with mud.
I think it's more mud than ash.
So back home, I will sample every individual volcanic deposit that we find in the cores. So I'm also looking at the tiny little millimeter scale deposits that we have in the cores in order to reconstruct a volcanic history of this field. So an eruption chronology reaching back to a couple of million years that we drilled.
The impact of any volcanic activity on Santorini can go way beyond its immediate surrounding. 3,500 years ago, the eruption was felt far beyond the island's shores. Its effects may have permanently weakened Minoan civilization and changed the history of the entire Aegean region. On Crete, as the heart of the Minoan realm, the impact would have been especially severe.
The population of Crete at this time certainly held a very central role in the Aegean, so from modern Greece to the west coast of Turkey and the Cyclades. Later historical records assign a thalassocracy, so a naval supremacy, to the Minoans. And you can find settlements right across the Aegean that bear a clear resemblance to Crete. In building styles, in their wall paintings, but also in their administration.
In fact, the Minoans influenced peoples throughout the Eastern Mediterranean, right up to the Egyptian pharaohs.
It was a big surprise when frescoes were discovered in a palace complex of the eastern Nile Delta, right on the Pelusian Nile. These wall paintings are very similar to those around Crete in their form of representation and their technique. So the cultural exchanges must have been much more extensive than previously imagined.
The fact that an Egyptian palace was decorated with foreign Minoan art is a testament to their position of power and influence.
One particular theme that we found in Egypt are images of bull-leaping traditions, with acrobats leaping over bulls, performing somersaults or flips, or grabbing the bulls by the horns. These bull-leaping scenes are only found in palaces. There are bull-leaping scenes in Knossos, so they're always in centers of power. And maybe that's why the pharaoh decided, this is a sign of an important political center. That's what I want too.
Such was the influence of Minoan culture throughout the Mediterranean that it even percolated through the power structures of ancient Egypt. But around the time of Santorini's eruption 3,500 years ago, a change sets in. There's evidence of the destruction of Minoan palaces. Their economic and cultural dominance begins to wane. Could the catastrophe on Santorini have triggered the collapse of Minoan civilization? To be sure, it's crucial to fully understand the eruption cycle and its exact date by combining different technologies. On board the JOIDES Resolution, Adam Woodhouse is preparing samples for a comprehensive biological dating of the different ash layers identified in the cores.
So my objective in the terms of this expedition is to use the organisms we've found within the ash layers to provide chronology to the Minoan eruption.
His method is based on the remains of microorganisms and has never been used to precisely date submarine volcanic deposits.
When we were looking at the ash layers, we always found the remains of planktonic organisms, organisms about the size of a grain of sand.
It's the amount of radioactive C14 carbon in the remains of the tiny organisms that will allow the dating of the eruption.
They are made of calcium carbonate and have tiny little shells, sort of like a bivalve or a mussel. These organisms evolved within the Jurassic. They've been around for a couple 100 million years, and they are still going strong today.
The countless microorganisms known as forams found in the ash layers of the volcano must have died together during the respective eruptions. Since then, their body's carbon content has been decaying at a constant, measurable rate. The extent of C14 decay indicates their time of death. For 2 months, the JOIDES Resolution raises sediment cores from the ocean floor around Santorini. Altogether, that makes almost 4 kilometers of volcanic sediment layers and several thousand samples for further analysis in the scientists' home laboratories. Will the samples rewrite the history of Santorini? At the Geomar Institute in North Germany, the chemical makeup of thousands of samples is being analyzed. Matching the chemical fingerprints of different ash layers with specific eruptions is crucial. Every event generates a unique chemical profile found in all of its deposits.
We analyze every shard of volcanic glass individually using the microprobe to detect the elements it's composed of, so how much iron, calcium or silicon. And that gives us the individual geochemical fingerprint generated by a specific eruption.
We use 2 methods to find this chemical fingerprint. It's similar to using a normal fingerprint together with DNA analysis in forensic science.
Und dann im Gegensatz dazu die DNA-Analyse. Und die Kombination.
So, the combination of the 2 methods gives you the irrevocable proof whether there is a match between an unknown sample and a known eruption. Or, if we could say, there's no overlap at all with a known eruption, so it must be from a new, previously unknown one.
The specific chemical fingerprints of different ash layers can now be matched with the results of seismic profiles of the sea floor. A research vessel sent acoustic signals into the ocean floor and recorded the echoes. The researchers could then generate structural impressions of the ash layers underground. Jonas Preiner and Katharina Punk compare their results at the Geomar Institute. The sediment layers identified by the acoustic profiles give a clear picture of the volcano's underwater topography and the thickness of different ash layers under the sea floor. These can be assigned to specific eruptions via their chemical fingerprints. The seismic profiles have identified completely unexpected layers in the seafloor of Santorini. Some had originally been dismissed as underwater landslides. Now the team has had to revise their conclusions. The geochemical data is clear. These sediment layers must have been created by a previously entirely unknown eruption of Santorini.
We made a really surprising discovery. Our preliminary hypothesis suggests that we're looking at one of the biggest eruptions of the Santorini system and probably the whole of the Aegean.
The results suggest Santorini suffered a gigantic eruption about 500,000 years ago, bigger even than the Minoan eruption. But why was it not previously identified in the volcanic ash layers found on land?
We have a very good record on land, back to about 300,000 years. But the record on land is inevitably incomplete because it rains, there's wind, and so this erodes, washes away some of the products. And then older eruptions are not preserved on land. But they are preserved in these sediments in the marine basins around Santorini.
The discovery of such a huge event confined to underwater deposits underlines how incomplete the land-based sediment archive is. Studying volcanoes like this exclusively on land and not in the surrounding sea means there are critical gaps in the records.
We just can't afford that. Remember that over 2 million tourists visit Santorini every year. An eruption like this would be far more horrific now than it was back in 1650.
The fact that these sorts of eruptions are possible in the part of Europe there is something to take into account. Very important, of course, to say that that doesn't mean an eruption like that's going to happen in the near future, but it shows that the Hellenic volcanic arc is capable of such eruptions.
Being able to predict volcanic eruptions is what we all aim for. We try to learn from the past. So, if we know exactly how this volcanic system around Santorini functions, we can also develop strategies as to which warning signals we really need to listen to.
Although the Aegean is used to the fallout of seismic activity, like the earthquake-generated tsunami of 2020, a big eruption of Santorini could have unexpectedly severe effects. The scientific insights gained from the Minoan eruption show that this volcano can be deadly. Though no evidence of human casualties has been found, there are strong indications that the eruption would have killed people.
The Minoans on Crete would have been watching this high Plinian plume. And then the next thing that the Minoans would have known about it was when the tsunamis arrived, because the entrance of these pyroclastic flows into the sea and the collapse of the caldera would have generated these waves, estimated maybe 9-10 meters on Crete. And these waves would have arrived at high speed and inundated the coast and destroyed some of their coastal towns. So they were the same sort of height as the waves from the Krakatoa eruption that swept onto Java and Sumatra in 1883, killing a lot of people. So these waves undoubtedly would have killed people.
Recent excavations along the west coast of Turkey support this theory. More than 200 kilometers from Santorini, near Izmir, the volcano also left an indelible mark. Here, archaeologist Vasif Sahoglu and his team are excavating ancient settlements along the coast. He's looking for evidence of catastrophic tsunamis. Recently, he made a groundbreaking discovery.
We found remains which looked like total chaos. We excavated a very well-preserved settlement with streets, houses, 10-20 meters next to it. Total chaos.
In 2017, Vasif Sahoglu and his team made an extraordinary find near the coastline at Çeşme Baglararasi.
We found volcanic ash which was coming from Santorini eruption. Plus, above and below the ash, we also found deposits which we later identified as tsunami deposits. And seeing what the impact of this tsunami 227 kilometers away from Santorini made, it literally wiped out the entire settlement in Çeşme Bağlar Arası.
The effect of the Minoan eruption on the peoples of the Aegean is still difficult to assess. The lack of human remains, despite the scale of the eruption, has left an unsolved conundrum.
Another very striking, let's say, discovery in our research was the skeleton of a dead man, which we found under big stones and within our tsunami deposits. This natural disaster must have killed thousands of people living all around the Aegean Sea. There must have been thousands of settlements and so many people living in these settlements right at that moment. We know that this happened, but then there was no proof of it until this moment.
The find at Çeşme Bağlar Arası was a breakthrough for the archaeologists. Clear evidence of the colossal scope of the Minoan eruption. Vasif Sohoglu is now hoping for further discoveries that could prove the horrific impact of the eruption across the Aegean. He too is looking for clues along the coast and underwater.
Of course, we have to think of Santorini way down, 227 kilometers south. Imagine the eruption happened and the tsunamis are coming in the Aegean towards the north. So all these southern coasts must have been affected totally. Let's think about this event in Çeşme. They must have heard the eruption of Santorini. And suddenly imagine the sea starts to grow and cover the land, and it's so strong and it must be very fast. And suddenly imagine the sea coming and destroying everything you own, people getting carried in the tsunami waves, in the water.
The archaeologists calculate that the eruption must have triggered at least 4 tsunamis.
We have this volcanic ash layer in between the tsunami layers, meaning there were times when it was all quiet, the water went back into the sea, so people, the survivors, must have thought it's over.
The tsunami waves would have arrived at the Turkish coastline within days, maybe hours of each other. The local population would have had time to return to the ruins of their homes, only to be taken by surprise by the next wave. The waves must have pulled everything into the sea.
We now begin to think that actually its impact must have been much bigger than ever predicted. Maybe we as archaeologists didn't really look for this enough in the past. Since Çeşme is so far away from Santorini and it had such a big impact, we believe all the coasts of Aegean Sea, Western Anatolian coast, the Greek mainland coasts, Cycladic Islands, northern coastline of Crete, they must have all been wiped out.
The discovery of just a single skeleton from such a cataclysmic event may seem meager, but it provides evidence that the Minoan eruption cost lives even hundreds of kilometers away. What does that mean for the island of Crete, so much closer to Santorini? Carl Nappit has been leading excavations on the Minoan harbor site of Palikastro on Crete's northeastern coast. The eruption must have taken people by surprise here, too.
The eruption would have sent up a huge cloud of ash, and that traveled in this direction. So it was clearly a really massive event here and pretty cataclysmic. People would have surely been very frightened. And if there was a tsunami too, then that would have been also a terrifying ordeal.
We can only speculate how the population reacted. The archaeological ruins offer little evidence of the human toll. But there are traces of ash deposits from Santorini in the remains of Palicastro. It's certain the fallout reached this Minoan harbour town. But how serious was the impact on the island's population? On Santorini, the eruption destroyed everything. The island remained uninhabited for hundreds of years. It was definitely lost to the Minoans as a seat of power. But on Crete, the effects were on a different scale.
Lots of sites on Crete, though, the people living on those sites at the time, they carry on living in the same place.
The excavations at Palicastro have unearthed signs that the ash was swept up, damaged homes were repaired and rebuilt, and a settlement persisted at the same site. It's likely the population recovered fairly well from the catastrophe. Just like people caught up in similar disasters today. The eruption of the Hunga Tonga Hunga Hapai volcano in January 2022 bears parallels to the Minoan eruption. It was one of the strongest eruptions ever recorded in modern times, more powerful than all nuclear weapons tests ever conducted. The island nation of Tonga was covered in a 5 to 10 centimeter thick layer of ash. A destructive tsunami followed. The ash layer and salt water flooding the fields ruined the harvest. High concentrations of sulfur dioxide generated acid rain. At least 80% of the population was affected by the damage. 3 months later, the rebuild was well underway, and the people of Tonga were looking ahead. Life simply carried on. That could have been the situation in Palicastro thousands of years ago, too. But was there a secondary, long-term fallout?
There's reason to believe there may have been more gradual impact, particularly on the capacity to engage in trade from site to site.
The ash from Santorini must have had immediate effects on people right across the eastern Mediterranean. Traces have been found scattered over a huge area. And that was due to the enormous size of the eruption cloud, catapulting ash 30 kilometers up into the atmosphere.
That's very high. That's about 3 times higher than you fly in a transatlantic jet. So you'd observed an enormous, great sort of column of billowing ash and pumice in the atmosphere, and then it would have reached about 30 kilometers and spread out.
This would have been presumably a pretty traumatic event for a lot of the inhabitants who would have never seen anything like this before. The ash would have fallen. It's a very sort of whitish green, powdery material with little glass particles in. So this would have covered the fields and the town.
But it's likely that people would have looked ahead and recovered. Just like the population of Tonga in 2022.
I think then it's clear that a lot of settlements just swept up, cleaned all the ash away, and carried on. So there's clearly a capacity to adapt.
They probably would have impacted shipping and coastal and harbours. So there would have undoubtedly been effects and mortalities. But on the scale of the entire island and the entire civilization, these wouldn't have been enough to have had a major effect on such an advanced people.
And yet, the eruption of Santorini may have triggered the unraveling of essential political and social structures of the Minoan rulers.
It might have destabilized or threatened their view of Knossos, the central power on the island, and its capacity to protect them in various ways.
Could the gigantic eruption at Santorini have caused the eventual downfall of the Minoan culture?
I think we have to be clear that there's about a century between the eruption and the demise of Minoan civilization. So a good 100 years. So it's really impossible to make a direct connection between the two phenomena. However, you could argue that the eruption is a kind of catalyst for what happens decades later with the Minoan demise or collapse. One idea is that the eruption could have had such profound social and even psychological effects on the population that some communities stopped trusting Knossos. And so this could have eventually led to infighting, turmoil, but it could have taken a long time. So the eruption may have been just the straw that broke the camel's back.
There are clear indications that Crete was plagued by civil unrest in the decades following the disaster. A new writing system suggests that a new elite took control of the island a few decades later.
We're not talking about the disappearance of the population or some people from outside settling the place anew. The local people will have continued to live here. But a new economic and likely also political system is introduced and established from the Mycenaean mainland.
The exact reconstruction of the Minoan eruption by the IODP team could provide important dates to support these theories. In Bristol, Adam Woodhouse is dating the submarine ash layers using carbon-14 stored in the remains of microorganisms. Because the team managed to isolate the remains of many microscopic forams in the ash samples, the hope is that the C14 dating can provide statistically significant results to support and refine the dates already gained from just a few terrestrial samples.
So the preliminary results that we've obtained from our forams is actually consistent with a date of the eruption somewhere between 1650 and 1500 BC. We have so much material from this expedition. We can keep performing these analyses and keep getting more dates, and hopefully that can refine this record much further. Dating the eruption and refining this date is important because this was an important time in human history, and understanding when this eruption occurred and what it potentially did to these early civilizations within the Mediterranean is important for understanding the human story as a whole.
Dating more microscopic forams from the ash layers of Santorini could produce statistical clusters of dates, refining the results gained thus far. 6 months after extracting the drill cores from the caldera of Santorini, the researchers meet in Bremen in Germany. The first results are discussed and analysis continues. 15,000 samples are taken within the space of just a week from thousands of core segments. The cores were carefully described and sampled on board the Joides Resolution, but now interdisciplinary examination can be deepened. The seismic data and geochemical analyses of the marine ash layers have generated a further surprise: evidence of an eruption that matches historical descriptions, but have never been identified in geological records on land.
It's fascinating that in the year 726, there was a historically documented eruption, and the historical records described the sea bubbling for several days. So there must have been gases rising from below, and at some point the water was full of pumice stones. Pumice is a volcanic rock with a very low density, so it floats. And these pumice rafts were found across the Aegean. There are reports that they even reached Constantinople, which at the time was the center of the known world, and blocked the passage to the Black Sea.
Historical records describe a huge eruption. Yet, aside from a thin layer of ash on the island of Pallia Kameni inside the caldera of Santorini, no evidence has been found on land. But underwater, the researchers could identify the eruption for the first time. Enormous ash layers confirm an eruption of gigantic dimensions.
In some places, it's up to 150 meters thick, and that's a really big event. And everything points to these being the deposits from the eruption in the year 726. So, when we see something like this, where there's hardly any trace left of an eruption virtually right next to the volcano, it tells us that our terrestrial archives are very incomplete. And that shows us that we can really only find out about these things by doing scientific ocean drilling.
But can our much fuller understanding of this volcanic history generate reliable prognoses?
So looking back in the past is one of the techniques that the volcanologists use to gain insight into how a volcano might behave in the future.
Based on the historical record, the team will generate risk assessments of future scenarios to identify likely danger zones. The aim is to create effective evacuation plans in case of a renewed eruption.
In Santorini's case, it's clear we're pretty much in the middle of Europe, and when this volcano erupts again, it won't just spell the end for a few sheep like in 1650. It'll mean serious casualties.
The current level of understanding suggests that a massive eruption like the Minoan one may not happen for several thousand years, but an earlier disaster cannot be discounted.
The generalities of a Santorini-type volcano is that it can have large explosive eruptions like the Minoan or the Archaeus, relatively rarely. Santorini has an eruption like that every 30 or 40,000 years. And an eruption like that would be pretty catastrophic, I think, in the middle of the Aegean, with all the islands around, with the tsunamis it would generate and so forth, and would certainly wipe out Santorini.
A volcano can be unpredictable, and that's why volcanoes need to be closely monitored.
And we're finding out, in fact, there are a lot of things recorded under the sea, eruptions that we didn't know about at all, that are giving us greater insight into how it behaves and enabling us to extrapolate our conceptual and even kind of mathematical models about how volcanoes behave back further into the past, giving us greater confidence about them.
We will likely need to extend the history of explosive volcanism at Santorini way into the distant past. And that means by several 100,000 years, which is pretty sensational.
The geological, biological, and historical research into Santorini will continue for months, even years, as, piece by piece, the volcano gives up its secrets. It's already clear that evidence found on land only holds part of the story. But underwater, deposits of completely unknown eruptions are preserved untouched, including the biggest eruption this volcanic field ever generated about 500,000 years ago. Assessing the danger posed by Santorini for the people and the environment of the Eastern Mediterranean is particularly urgent. If nothing else, the impact of the Minoan eruption is evidence of how destructive this volcano can be. Eruptions like this, affecting the climate, harvests, the water supply, destabilize entire societies. The Aegeans' Minoan superpower must have battled with the fallout over many years. Its downfall was only a matter of time. The preliminary insights gained by this revolutionary IODP expedition are clear. This volcano should not be underestimated. It will continue to dominate the Aegean for thousands of years to come.